Hello and welcome to part 3 of setting up an OpenFOAM cluster. In part 1 we went through the hardware that I bought secondhand and cleaning of that, and then the second part was installing Ubuntu on the servers, the IBM System X3650s. Now that we've installed Ubuntu on the two servers and also the S20s, I'm just going to show you we're going to connect them all together so they can communicate, have a shared file system, and running the OpenFOAM software or OpenFOAM case. So for this system, we're going to have the master and slaves. Uranus will be the master, and Gaia and Cronus will be the two slaves. We'll use the SSH protocol to communicate with each other. And then we'll set up an NFS system for them to have a shared file system. And then after that, we will run an OpenFOAM case. So let's get started. The first thing we must do is just make a directory in our home directory that's hidden. That's what the dot is for, to keep our keys in. After that, we just need to change the modification, so only you can have access to your keys. And after that, we generate a key. Yeah, you just push enter, you don't want a passphrase, and there we go. So that's the key done for the master. Let's do the same now for slaves. So I'm going to log in again. Okay, let's try again. Here we make the generate the key. Okay, now that the keys are all generated on all our systems, we've got to copy the one from the server to the master to the two. to the other two slaves. And then that's the password for the slave, so there it was copied. So then it says we can use SSH go at 192.168.1.102, and then we've logged into Gaia without a password. And then we must just do the same for number 3. Yes. And then we're logged into Kronos. So now from Kronos we use ssh.copy id -i. Oh, sorry. Now the last one. Let's just test it. There we go. Okay, now after that we've got to set up a shared file system, and what we'll use is the OpenFOAM directory in each of them that gets set up already. So what we need to do is install NS server on the master and NFS common on the slave. So apt-get install NFS kernel server. It's going there, and then on the slaves we'll do sudo apt install NFS common. That's already installed there. And there it goes there. And then from that we will make a directory which we've already made at OpenFOAM. And then we will just change the owner to everyone. Okay, and then the next thing we need to do is change the access. Okay, now then we've got to export the folder that we just created. That is, we've got to modify the exports folder, which is part of the NFS file system. I just want to remove this one because this is from a test. and I have that saved on the side, so we'll just need these two. So these two, one, we save the directory and then which IP address we want to export it to, and then we use the read write, no sync, no subtree check, and then we save that. And then after that we go over to the, let's just export it. And then restart the service. And then the last thing is just make sure the firewall is inactive on the master. Now we go over to the site, to the slaves. So here what we do is we edit the FS tab or FS tab file, which has all your mounting on. So we need to mount this drive now for how we mount the network drive onto this computer. So, and what we will use is this, the format here. So we have the IP address of where it's from, the mount point. So this is the file system, this piece here. Where we're going to mount it, we're going to mount it on OpenFOAM. What type it is, NSF, and then there's options, defaults, just as this example is here. Okay, and then we write that out, and then we're going to mount. Just want to show you here first. OpenFOAM already has some items in, so I just want to remove API hello. And then, there we go, mount just go into this OpenFOAM, and you'll see there's a whole lot of stuff there as well from a previous test. So if we list here, there's only 2 folders in there. So now we're going to mount all, sudo mount all, and there you can see we went from having a lot of folders to just having this motorbike. And so then if I create one, I go touch file for Kronos. Unless here there'll be a file for Kronos. So now we do the same on Gaia. sudo nano etc fs tab NFS defaults 00. Just checking the spelling, and then sudo mount all, and then we use the, now if we go into OpenFOAM, see the file for Kronos, and now we go touch Gaia, and there's file for Gaia. So now we can log into each computer from the master, and the slaves can go into the master, and now we can also have a shared file system. So now the next thing is to test out the MPI hello. And to do this, we are going to run a small program. And I found one on the internet. Here it is from, I'm not quite sure, it's a university in America. And we are just going to copy this and paste it here. And then we going to compile it, npicc, npi loc, dash output, npi underscore hello. And it's compiled. And then to run it, it should be hello from Uranus. So now there's a problem. Let's do npi run dash np12. And there's all 12 CPUs. But now we've got to be able to access the other servers. And then if you look here, they all have access to the MPI hello program. But to be able to communicate with each other, you got to tell MPI where it must communicate with and who it must communicate with. So to do that, we have a host file. And in this host file, we will say what machines we're going to be using, and also the number of slots on each machine. So there we have Uranus, Gaia, and 2 slots from Kronos. And then what we're going to do here is MPI run dash MP 26 with host file host text MPIC spelling. And there we go, Uranus, Gaia, and the 2 from Kronos. Okay, now I need to run the OpenFOAM case. So let's change to that. Just check where we're going. So from my previous testing, let me just clean it, and then I need to run it. Actually, get all run. So what I need to do is here, not this one, CD motorbike. I need this file. So then if we go CD constant driver surfaces, there's the motorbike. Okay, now we just need to remove that one and then go into the system directory. And then we're going to modify these decomposed digs to the correct one. So we've got nano decomposed dict. We've got 26 domains. Apologies, I haven't tested. I've got to think what how many subdomains I'm going to be using. Just want to see if this works, because didn't test it with all 3 yet, so I've tested with 2. That's why the 24 was there. Sorry. So now we've changed the decompose tick, so it should, in theory, do 4. So what we should have to do is block mesh. To run the block mesh, decompose par. It's created a 26 files, and then what we should have to do now is run the MPI with the host file, which let's just have a look and make sure it's correct. No, it's not. Let's get these here. Okay, so MPI run. And so we've copied the geometry. We ran block mesh, we decompose, and now we're going to run snappyHexMesh. So in theory, normally you run MPI run -np26 with some host file machines, and then snappyHexMesh.parallel. Let's see, and there's a problem. And the problem is that it's saying it can't find the executable on the node. So it's trying to go to this place and find it. And the fix for this was actually we're calling the wrong MPI or the wrong directory for the executable. So what we should have used is foam job-p snappyHexMesh, and there it's going. So if we go on htop here, there it's saying snappy is running there. Htop snappy is running here. But now let's actually check. And here you can see with the executable before we check the log file. So it's wrote a log. It's used this whole directory here to run the parallel. And so it's stating exactly where the MPI run is. Using foam job uses the machines file that looks for the machines, and then it's going to this foam exec and run snappyHexMesh.parallel. And it looks like everything is running. But let's have a look at the log and emojis and have a look. Oh, and it's not actually running because there's a TCP problem. So it's having this MCA BTL TCP endpoint, some problem getting to Gaia. And from what I can gather, that problem has got to do with I just want to kill Snappy on this side. So just interrupt the MPI and then it'll stop everything there. So on these servers, there's multiple IP address or network cards, so there's multiple IPs. So I think it's getting a network problem. But I managed to find it by tuning the MPI, the OpenMPI software, by adding an extra line here. This -MCA BTL underscore TCP underscore if include, and then you've got to have only these IP addresses that will use that fall under this format. And then I must just change this here. To 26, and then we enter. And there you can see now we are running on Uranus and Gaia up at the top there. Let's see if I can get there. But now you can actually see it's running properly. And that is how you set up the OpenFOAM to run on a cluster. In the end, you got to learn a bit of MPI, OpenMPI to run it. And a bit of Googling will help as well. But I hope you found this little tutorial useful. Maybe you've got some spare computers or you're running a little project for university, that this will help you to set up a cluster a bit easier. And I hope you enjoyed it. And remember to subscribe and look forward to seeing you again. Okay, bye-bye.